In today's class, we are going to take a tour into the world of atoms and molecules. The picture here shows a river, and a river is a matter. Everything around us, the trees, the river, just like you have seen here, the air we breathe, they are all matters. Matter is anything that has mass and occupy space. Matter is anything that has mass and it occupies space, or you can also call it volume. So matter is anything that has mass and occupy space. The entire world is made up of matter. From this river here, we can come down to a small glass of water. This is a glass of water. From this glass of water, we can go smaller to drops of water. So this is a drop of water made up of tiny particles called molecules. And the molecules cannot be seen with naked eyes, but rather with electron microscope. Okay, we can see drops of water, but we cannot see the molecules of water. Okay, now what is molecule of water made up of? So water molecule is made up of tinier particles called atoms. Tinier particles called atoms, as we can see here. So this water particle or molecule has hydrogen, it has hydrogen atoms, and this is oxygen atom. So we have three atoms in a molecule of water. We have two hydrogen atoms and one oxygen atom. So there we have it as two, that's H2O. This shows that we have two atoms of hydrogen and one atom of oxygen. All right, let's see structure of an atom. So here, atom is gotten from a Greek word meaning atomos, meaning atomos. This is a Greek word, and this atomos means indivisible. Indivisible, or you can also call it uncuttable. Uncuttable. Imagine you have something like a piece of paper and you keep cutting it until the piece of paper is unable to be cut again. So you can call it an atom. An atom is defined as the indivisible particle. That is indivisible particle, indivisible particle that takes part in chemical reaction. In chemical reaction. That is atom. Now, it was thought to be the tiniest particle, but it was later discovered that atom could be divided to smaller particles called electron. Then we have the proton and the neutron. So the proton and the neutrons are found in the nucleus. Here is the nucleus of the atom, which is much denser. So in the nucleus of an atom, we have the proton and we have the neutron. And the proton is positively charged particle, and the neutron has a zero charge or neutral, while the electron is negatively charged. Electron is negatively charged, the proton positively charged, and the neutron is neutral or zero charge. Matter is made up of tiny particles called atom. Now, one thing you have to understand also is that different atoms have different sizes. Different atoms have different sizes. Okay, here from river, we have a glass of water. Then from the glass of water, we come down to drop of water. Then from drop of water, we come down to water molecule, which cannot be seen with naked eye but with electron microscope. Then from there, we now come down to atom. All right, so let's look at atoms of different elements. Atoms of different elements. So here we have hydrogen atom. This is hydrogen atom. This is hydrogen atom. This is helium atom. This is helium atom. So this is oxygen atom. This is oxygen atom. So this is sodium atom. Sodium atom. So for this, we have this as chlorine atom. Chlorine atom. Okay, atoms are important because chemical reaction take place based on atoms. So let's go ahead and look at molecules of elements. So we have molecules of elements. So here, molecules of elements, are made up of atoms, that is one or more atoms. One or more atoms. So when you're talking about molecules, you see that molecules are made up of one or more atoms. They are made up of one or more atoms. So let's take an example here. This is hydrogen atom. So for this to be a molecule, so we have to add another hydrogen atom here. Another hydrogen atom here. So you see, we now have H2, which is two hydrogen atom, which is two hydrogen atom, two hydrogen atoms. So this is molecules of elements. Remember that molecules are made up of one or more atoms. So here now, we have two atoms here, atoms of hydrogen making up a molecule of hydrogen. Okay, so let's look at this. We also have helium. Helium, that is, it has only one atom. That's one helium atom. The reason because it is a noble gas, so it doesn't want any friends, so it stays alone. So it's one helium atom. So let's look at oxygen here. Oxygen will require a friend. Yes, to require a friend. So we also have oxygen here. Therefore, we have two oxygen, that is two atoms of oxygen. Two oxygen atom. Have two oxygen atom here. So for chlorine, this for chlorine. So chlorine we also have to combine with another chlorine. So we have two chlorine atoms. Two chlorine atoms. So which is written as Cl2. So for sodium, sodium has only one atom, one sodium atom, one sodium atom. And the reason because sodium has atomicity of what? 1. Sodium is a metal, and all metal have atomicity of what? Of 1. All right, so let's look at atomicity. So what is atomicity? Atomicity is the number of atoms present in one molecule of an element. The number of atoms present in one molecule of an element. That is what atomicity means. We also have monatomic. Mono means one. Mono means one. So you see, and diatomic, based on the table we have here, is what? Is 2. So, and the triatomic is 3, while tetratomic is 4, and octatomic is 8. So here, monoatomic elements are found here. You have from helium, neon, argon, krypton, xenon, and all metal. And all metal. So you will have the atomic, we have the oxygen, we have the hydrogen, nitrogen, fluorine, chlorine, bromine, iodine. All these are diatomic elements. So we have triatomic, we have the ozone, we have the tetratomic, the phosphorus, and we have the octatomic, the sulfur. So here, I will just quickly give you useful rules. Here, metals are considered as monatomic. So all metals are considered as what? Monatomic. So metals are considered as monatomic. Monatomic. So usually solids can be written as monatomic, even though their atomicity may be greater than 1. Like for instance, let's look at phosphorus. Let's look at phosphorus. Let's look at phosphorus. So phosphorus here, let's look at phosphorus is solid. So it can be written as P. It can also be written as P4. Even sulfur. Let's look at sulfur too. Even sulfur. Sulfur can also, we have sulfur. Sulfur can also be written as X or SO8. So these are the way you can write sulfur. X8, sorry, okay. Sorry, which is X8. So many gases have atomicity greater than 1, but all noble gases are monatomic in nature. All the noble gases are monatomic. You have seen our helium, neon. They are what? Noble gases, and they have atomicity 1. Remember that atomicity is different from valency. So let's go ahead and check out for valency. So this is valency. Valency is the combining capacity of an element with other elements. The combining power or the combining capacity of an element with another element. With other element. Okay, here, let's look at hydrogen here. Let's look at hydrogen and chlorine. So let's see, we have hydrogen, we have chlorine. So when they combine, we'll have hydrogen chloride or hydrochloric acid, which happens to be a compound. Which happens to be a compound. So here we have it that one atom of chlorine will combine with one atom of hydrogen. Is that understood now? To give us hydrogen chloride. So here, valency of chlorine is what? Is 1. Even valency of hydrogen also is 1. Okay, let's look at hydrogen and oxygen. So let's have hydrogen plus oxygen. So you will see here that 2 atoms of hydrogen will combine with 1 atom of oxygen to give us water. To give us water. So water here is a compound to give us water. So we have 2 hydrogen atoms and 1 oxygen atom combining to give us water. And here, valency of oxygen, O is equals to 2. Now, let's also look at nitrogen combining with hydrogen to give us ammonia. So you see here, we are going to have one atom of nitrogen combining with 3 atoms of hydrogen atom, 3 atoms of hydrogen to give us ammonia. So here the valency of nitrogen is equals to 3. So valency is the combining power or capacity of an element with other elements. So let's go ahead and see. Okay. So let's look at molecules of compounds. Let's look at molecules of compounds. Molecules of compounds. Molecules of compounds. So here we have sodium combining with chlorine. So we are going to have sodium chloride. We are going to have sodium chloride, which is our normal salt. The salt we use in cooking food. But one good thing about this is that their combining power is what? Is 1. That's the valency of sodium here is what? Is 1. While that of the chlorine is what? Is 1. Is 1. All right, so let's look at sodium oxide. Let's look at sodium oxide. Sodium oxide. So here we'll see that 2 atoms of sodium is combining with 1 atom of oxygen to give us sodium oxide. Now note that when non-metals bond with non-metal, they form a covalent bond. That is, non-metal bonding with non-metal. So they form what we call covalent bond. Covalent bond, which means sharing of electrons. Sharing of electrons. Which means sharing of electrons. So metal and non-metal. So when metal bond with non-metal, we have what we call ionic bond. Ionic bond, which has to do with transfer of electrons. Okay, like here, the case of sodium and chlorine. So the case of sodium and chlorine. So sodium here loses. Sodium loses electron and chlorine gains. Chlorine gains the electrons. And they form what we call ionic bond. Ionic bond. Sodium is a metal, while chlorine is a non-metal. So their bonding results to what we call ionic bonding. Okay, let's quickly take some exercise. What is the valency of sulfur in sulfur dioxide? What is the valency of sulfur in sulfur dioxide? So I'm going to show you a simple trick to go about that. So here we have sulfur and we have oxygen. You know that the valency of oxygen is 2. So I am looking for this valency of sulfur in sulfur dioxide. Now we have it as X. So let's take the valency of sulfur to be X so that we can calculate it. So what are we going to do now? So we have to use the crisscross method. So I'm going to take crisscross what method. So which is not going to be, so it's not going to be X2 O X. Now you ask yourself, what value of X satisfies the answer? So we can start testing. So we can test X equals to 1, 2, 3. So here, let us assume that X is equals to 4. So when we now have X2, then O4. So that means we have replaced X with 4. So here, 2 we cancel itself 1, cancel 4, we have what? 2. So we have it as XO2. So this is the molecular formula for sulfur dioxide. That is to say that the valency of sulfur in sulfur dioxide is 4. So the valency of sulfur in sulfur dioxide is what? Is 4. Okay, let's take the next one. What is the valency of sulfur in sulfur trioxide? So we have the formula for sulfur trioxide as SO3. So what is the valency of sulfur in sulfur trioxide? So what we're going to do is, as usual, we have our X. So we'll take it as X as the valency. We'll take the valency of sulfur as X so that we can find it. And we know that the valency of oxygen is what? Is 2. So we use crisscross method. So these 2 will come to X to sulfur, while X will come to oxygen. So we have it as S2, then oxygen X. So we are going to find X. So what value of X satisfies this equation? So we are beginning to test. So we can test 1. If you test 1, you will see that it will not satisfy. Then we test 2, test 3. So we can go ahead and test 6. So if we replace this X with 6, so we can now have X2, that is when X is equals to 6. So we now have 0, we have what? 6 here. So these 2 we cancel itself, we have only X. So the 2 will cancel this 6. We have 3. So we have XO3. So you see that this is this formula for sulfur trioxide. That is to say that the valency of sulfur is 6. Molecules of compound. Let's look at molecules of compound. Molecules of compound. Okay, here we have our hydrogen, we have oxygen, sodium chlorine. So we can decide to combine these two, which we have done earlier. If you combine that, so we have sodium plus chlorine, so which gives you sodium chloride. So here we can decide to combine any of this to get a compound. So here you see that you have different molecules. So we have this molecule of one molecule of sodium, and also have one molecule of chlorine. So both of them combining together will give you compound, molecules of compound. Okay, let's go ahead and take these examples. Write down the molecular formula of the following substance. Write down the molecular formula of the following substances. So what is the molecular formula for nitrogen? Of nitrogen. So nitrogen, is it going to be N or N2? So the value, the answer is going to be what? N2. It's going to be N2. So nitrogen always exists as what? As diatomic. Okay, let's look at neon. Let's look at neon. So what is the molecular formula for neon? Is what? Is Ne. So what about that of aluminium hydroxide? Aluminium hydroxide. Aluminium hydroxide, you can see that for nitrogen and neon, they are elements. Nitrogen is an element, neon is an element. So when you are looking at the molecular formulas of elements, the trick is make use of their atomicity. So for elements, use atomicity. Use atomicity. When you are trying to get the molecular formula for elements, use the atomicity. So here, aluminium hydroxide is a compound. So when we are trying to get the molecular formula for compounds, you are going to use valency. So you use valency. We are trying to get the molecular formula for compound. Use valency. So let's look at aluminium hydroxide. Now, aluminium hydroxide, the valency of aluminium hydroxide is made up of aluminium and hydroxide. Now you see that aluminium, the valency of aluminium is plus 3, is 3. And that of the hydroxide is 1 or -1. So what we're going to do to use crisscross methods, we're going to use crisscross method, or we exchange their valencies. Exchanging their valency, that means hydroxide will not take the valency of aluminium, while aluminium will not take the valency of hydroxide. So if we do that, we are not going to have aluminium taking valency of hydroxide, which is 1, and hydroxide taking valency of aluminium, which is 3. So we have 0H3. So in this case now, because this hydroxide is made up of oxygen and hydrogen, so it's going to be in brackets. So this 3 is multiplying the oxygen and also the hydrogen. So this becomes the molecular formula for this compound, aluminium hydroxide. So remember that whenever you want to get molecular formula of a compound, you are going to make use of the valency. All right, let's go ahead. Write down the molecular formula of the following substance, ammonium hydroxide. Ammonium hydroxide. So let's look at ammonium hydroxide. So here, ammonium hydroxide, so it's made up of ammonium and hydroxide. So which is NH4 and hydroxide. You see that now? And hydroxide. So ammonium has valency of 1 and hydroxide also has valency of 1. So using crisscross method or exchanging their valency, it will result to NH4OH. So this is the formula for ammonium hydroxide. So let's look at ferrous chloride. Ferrous chloride. Ferrous is what is ferrous. So here, ferrous is Fe. So, and we have chlorine, Cl. So, the valency of ferrous is 2, while that of the chlorine is 1. So, we exchange their valency, or what we call crisscross method. So, we will now have chlorine will not take valency of ferrous, while ferrous will not take valency of chlorine. So, we now have it as ferrous chloride. So this now becomes the molecular formula for ferrous chloride. So let's look at ferric chloride. So ferric has valency of 3. And we know that chlorine has valency of 1. So let us exchange their valency. So when we do that, we have Fe, then Cl3, so which gives us ferric chloride. So remember I told you when you have a compound, please make use of their valency. Okay, let's look at cuprous oxide. Cuprous oxide is made up of copper and oxygen. So we have copper, Cu, and we have oxygen. And of course, you know that the valency of copper is 1, while the valency of oxygen is 2. So let us exchange their valency. So copper now takes the valency of oxygen, which is Cu2. Then oxygen takes the valency of copper, which is 1. So this gives us cuprous oxide, the molecular formula. So let's look at cupric oxide. Cupric oxide. So cupric oxide is also made up of copper and oxygen. Then cupric has a valency of 2. Cupric has a valency of 2, why oxygen also has what? A valency of 2. So let's exchange their valency. So when we do that, so we now have Cu2 O2. So 2 we cancel 2. So we have CuO. So CuO is what? Is cupric oxide. Is cupric oxide. So for copper oxide is the same thing as cupric oxide. So copper oxide is same thing as cupric oxide, which is CuO. All right, let's look at calcium carbonate. Calcium carbonate. So calcium carbonate is made up of calcium, Ca, and carbonate, CO3. And the valency for calcium is 2. And that of the carbonate is also 2. So we exchange their valency. So which will have Ca2, we have CO3, you put it in brackets, 2. So these 2, we cancel these 2. So we have Ca, CO3, which is calcium carbonate. So this is the molecular formula for calcium carbonate. You have to make use of the valency for you to write down molecular formula of compound. So calcium bicarbonate. Calcium bicarbonate. Let's look at calcium bicarbonate. So it's made up of calcium and bicarbonate, which is HCO3. And calcium, we know, has a valency of 2, while bicarbonate has a valency of 1. So let us exchange the valency. So here we have Ca, then HCO3. So this becomes the molecular formula for calcium bicarbonate. Okay, let's go ahead and look at lead 2 oxide. This one is very simple. Lead 2 oxide. So that's lead 2 oxide, which is lead is Pb. So the 2 shows it has valency of 2. So we have valency of 2, and oxygen, which also has a valency of 2. So we exchange valencies. We have lead 2 and oxygen 2. So 2 we cancel 2. So we now have PbO, so which is the correct molecular formula for lead 2 oxide. So let's quickly look at lead 4 oxide. That is Pb4, valency of 4, then oxygen is 2. So crisscross, or we're changing the valency. We now have Pb, Pb2, then we have oxygen 4. So 2 will cancel itself. We have Pb. We cancel 4. We now have oxygen 2. That's 2 atoms of oxygen. So this now gives us lead 4 oxide. All right. So we'll see in the next class. Please do well to subscribe to the channel and share with your friends. Thank you.